Okay, so let's take a look at example 3, page 13 in your book. Alright. So example 3 says, Kyla buys an oversized wooden barrel. She cuts it in half and makes a planter. She wants to place a metal band around the planter 4 centimeters from the top to hold the planter together. So let's just take a look at what that looks like. Let's see if I can get a brown color here. So you guys ever seen these before? Barrels turned into planters. So there's my barrel, sawed in half. Okay? And then you put dirt inside and grow stuff out of it. You got that? Okay. So, what she wants to do is she wants to create a band 4 centimeters from the top to hold it together. So, I'll draw it a little closer. Here's the band right here. It goes all the way around the planter. And let's see if I can color it a little bit. There. Okay, good. So in A, it tells us that the radius 4 centimeters from the top of the planter is 0.6 meters. Okay, so this distance is 4 centimeters, right? Because she wants the first band to be 4 centimeters from the top. And the radius at that point is 0.6 meters. What does that mean? The radius.
It's like from the center to the other side.
Yeah, from the center of the barrel. Here's the other side of the barrel. At the band there. Actually, I should do that in gray. So here's the other side of the band. If you could see through the barrel. And then the radius goes from the center at that point to the edge. And that's 0.6 meters.
Yeah.
You can visualize that? Okay. What length of band does she need and to ensure that it hugs tightly to the barrel at that point?
There's that formula.
Yeah, that formula for what? Essentially, this is going around the outside of a circular object. What's the outside of the distance around the outside of a circular object called? It's called the circumference, right? So essentially, we're looking for the circumference at this position on the barrel. You follow?
Mm-hmm.
So circumference of a circle is equal to
Pi r squared.
Pi r squared is the area.
2 pi r.
2 pi r. So 2 times pi times r. Okay, good. They want it to the nearest centimeter. So there's something we have to do to our radius first in order to get it in centimeters. All right, we gotta convert it. So just using what we've done before. What's the conversion factor here? Meters to centimeters.
Yeah.
How many centimeters in a meter? 1 meter is 100 centimeters. Okay, so what goes where? 1 meter goes on the top or the bottom? Bottom.
Yeah.
Alright, I wanted to cancel those meters. And then the 100 centimeters?
Top.
On top, good. 1.3 is going to be a breeze for you guys now. Alright, so basically that's 0.6 times 100. What do you get? 60? Good. 60 centimeters. Which makes sense. That's 1/10 of a meter. Or sorry, 6/10 of a meter. Okay, so the circumference, now we can get this in the proper units, is 2 pi times r, which is 60 centimeters. What does that equal?
3.7699.
3.7699? No. It's going to be much larger than that. 2 times pi times 60. In your calculator, you want to do 2 times pi times 60. That's what you want to enter.
I got 376.
Yeah, 376 point.
Well,
I got 376.99.
Sounds like everyone got the same thing.
Yeah.
376.99.
Yeah.
Okay, I'm just going to round it to
It's
377.
got a whole bunch of numbers in it.
Yeah, they say it's rounded to the nearest centimeter, so we're going to round to 1, or no decimal place values, to the nearest whole centimeter. So that's the circumference of the barrel at that point. That's how long that band of metal is going to need to be in order to perfectly fit around the barrel at that point. Good? Okay. Let's go and read B here. It says if the bottom band, so there's another band of metal that she's putting on. You can kind of see that in the picture there. You see the two bands of metal on the barrel. She says, or it says if the bottom band of her planter is 1 meter shorter than the top band, what's the radius of the planter at the bottom band? Okay, so here's the bottom band. We'll draw it a little smaller than what we had before. Shade it in. Okay. Now here's an important thing to think about. Do we know how far that bottom band is from the bottom of the barrel? Does it say?
So it's,
No, it doesn't. Does it tell you how far it is from the top band?
Yeah.
How far is it from the top band? It doesn't tell you that either.
it's,
What are they asking?
they want to know like the difference in the radius.
They want to know the difference in the radius. You're right. Okay, so let's draw that. So there's a radius here at the bottom band. I don't know what that
It
is.
says that it's 1 meter shorter than the top band.
Yeah.
Did they say the radius is 1 meter shorter?
Mhm.
What do they say? Read it carefully.
The circumference.
The circumference of the band is 1 meter shorter than what we just had. Okay, so what's the circumference of the top band? We just found that.
377.
377. What's 1 meter less than that?
376.
1 meter
Oh.
less than that. Think about it.
Oh, 2 point?
277.
277. Why?
Because it's a meter, not a centimeter.
Yeah, you're taking 377 and you're subtracting, or 377 centimeters. To subtract a meter, you got to convert it to
Oh.
centimeters. Yeah. So we're taking 100 centimeters off. That's the same thing as a meter, right? So that gives us 277 centimeters for a circumference at that bottom band. Okay. Could I now figure out the radius using the circumference? Is that possible? Probably. Let's give it a try. So the circumference at the bottom, again, is always equal to 2 pi r. This time, however, I know the circumference, but I don't know the radius. That's what I need to find.
Well, could you do like the circumference, and then something with the 2 pi to get the r?
Yep. Think of 2 pi as a coefficient of r. What do you do with coefficients? Do you remember?
They multiply.
It's multiplying r, so undo that, we
Divide.
divide, right? It's similar to having something like 277 equals 3 times some variable. To get rid of that variable, you divide both sides by 3. Right? A similar situation is happening here. 2 pi, just think of that as a single number, is multiplying our variable, so to get rid of it, we divide it out. Now I have to warn you, when you do this in your calculator, make sure you enter, that's a really bad pi, make sure you enter the following. You enter 277 divided bracket 2 pi. Very important that you put those brackets there. Okay, if you don't put the brackets there, your calculator thinks you're doing this. That's something very different.
Yeah, because I did that and it gave me some.
Okay? Make sure that if you're dividing by multiple things that are glued together, you put the whole thing in brackets. Okay, so what is the radius?
44.085.
And can someone...
I just put .44.
44...
Oh,
Is that correct?
Yeah. That's
Okay. 44 centimeters. Does that seem reasonable? We had a smaller circumference, so therefore the radius should also be smaller. Let's see, what was the radius before in centimeters? At the top.
centimeters.
Yeah, what was the radius in centimeters? We had 60 centimeters for a radius here. And what do we have at the bottom now?
40.
About 44 centimeters. Is that reasonable? Does that seem...
That's about right.
Yeah, okay. That works. Good. What's the difference between those two? That's what they're ultimately asking us. Well, we can just take 60 and subtract 44. Yeah, we'll round it to the nearest centimeter. That's a difference of how much?
60 minus 40. That's 16.
16 centimeters, right?